welcome to the AI for You Cafe today. Today I have the speaker, Ki Bai Han. He is Assistant Professor of Data Science and Business Analytics at Nova School of Business and Economics in Portugal. With his talk on the effect of product placement on shopping behavior at the point of purchase. Evidence from randomized experiment using video. My name is Carmen McWilliams, and I'm the moderator and organizer of this cafe. I'm the director of the company Grassroot Arts and partner in the AI for You project. So everybody, again, great you're here, and thank you. Soon Kibai will speak, but first I will introduce the regulations, rules in our cafe. Please take notice that the session will be recorded. No confidential information shall be shared in this cafe session. In this cafe, the speakers express their personal view and opinions. This is not necessarily the official AI for You project opinion. Again, this is an interactive session. As you know, please write your questions in the control panel on the right side. There is a chat question, and you just type them in, and I will read them to the speaker afterwards. Now we're coming to our main reason why we are in this cafe today. I shortly introduce you. Hello, Kibai. Hello.
Hi. Hello.
Hello. Great you're here. So I take a minute to introduce you, and then the floor is yours. Ki Bai Han is currently an assistant professor of data science and business analytics at Nova School of Business and Economics in Portugal. He is an affiliated faculty with the Data Science Knowledge Center for Nova SBE. He received PhD in engineering and public policy and a master degree in information networking from Carnegie Mellon University in the United States and Instituto Superior Técnico from Portugal. His research is at the intersection of econometrics and machine learning, using complex data-driven approaches on a variety of projects with societal impacts. He served as the technical mentor for Data Science for Social Good Europe program, jointly offered by Nova SBE and the University of Chicago in 2017 and 2018. His research appeared in data science and information system conferences, and he received the Best Paper Award from International Conference on Social Computing. So, Grain, very impressive.
Okay.
And thank you, you're here, you're joining us. So now, Kibai, I will give you the moderator role, and you can start introducing yourself and your presentation.
Okay. Thank you very much. So thank you very much for having me today, and thanks for the introduction from Carmen. And today I'd like to talk about a research that I did previously with my PhD advisors, Professor Pedro Ferreira and Professor João Paulo Costela at the Instituto Superior Técnico, that we are trying to identify the effect of product placement on shopping behavior using the randomized experiment. And one of the contributions that we have is trying to use the video tracking as a way to monitor and track the shopper behavior in the physical retailing environment. And before I started, I would like to give acknowledgement to the supporter that we have received massively during the entire project. So it's being supported by the Portuguese Foundations for Science Technology, also known as FCT, and also through the Carnegie Mellon Portugal program. So we have received a lot of support from the Technical Lisbon, Institute for System and Robotics, ISR Lisbon, and also the Carnegie Mellon Portugal program through the FCT fundings. And the project also benefit a lot from our the Livraria Barata, a bookstore that provide us the experimental setting, and João Carvalho for his technical support. Okay, so today I would like to introduce you the topic and why it's important, and I'm going to also talk about how the experiment is designed and how we collect the data through the in-store tracking infrastructure. And after we collect the data, we build up a model to identify the causal effects between the product placement and shopping behavior. And I'm going to show you some very interesting results that we have obtained and what are the discussions and implications afterwards. So we are all at the very edge of talking about the future of the physical retailing nowadays, because as we might know that the business performance of the physical retailing industry is actually is actually at the falling stage that is being challenged by the falling profit margins, rising cost pressures, and intensified competitions with online retailers. So probably you have noticed that a lot more people have started to go shopping online, and the online retailer giants such as Amazon are actually taking a lot of the lion's shares of the retailing from many of these local physical stores. So in fact, the Forbes magazine reported that just this year, there are about 14,000 physical stores closed in the US as of November 2020. And that is about 56% jump from the 2019. This is actually one of the reasons is that the e-commerce sales actually has been increased significantly over 50 times from 1998 to 2013. So as you can see that we are actually reaching to the stage of what's called the physical retailing apocalypse. That actually is further exacerbated by the COVID-19 pandemic, because given the strict mobility restrictions, people cannot go outside to shopping as usual, and then instead they are increasingly further resort to the online channel to make the shopping. So what will be the specific challenges associated with the physical retailing? One of the things that the IT-related advances actually facilitate online retailer to maintain almost unlimited yet personalized virtual inventory. So if you can think about the bookstore, okay, so the number of the book titles available at Amazon is much more than any this physical bookstore that it can accommodate, because it does not really need this shelf space in order to store and accommodate all the different book titles. So by contrast, retail stores are still can only stock and display a very small set of the products due to the fundamental shelf space constraints. So there is no way for any this physical store that can store up to millions of the book titles, just like what Amazon does. And on the other hand, online retailers can also adopt many of these IT-enabled features, such as price comparison and recommendations that would acquire information about product and price at much lower costs. So this has two implications. First is that it will reduce the search cost and uncertainty from the shoppers, so that they can easily identify the products that they like. Second is that it also increases the sales through the upselling and the cross-selling via the recommendation engine. So probably you are very familiar with the scenario that whenever you browse the online retailings, that you will see the page that says the products the user like will also buy those ones. So these are considered as some cross-selling opportunities, where in the physical retailing it's nearly impossible. But whenever we talk about the shopping journeys in the physical store and in the e-commerce sites, actually it's surprisingly the same process. So if we look at the physical stores, a shopper needs to enter the store and search for the items that are located on the shelves. And then they need to pick up those products and evaluate these items and give a valuation about it. And once they are happy or satisfied with the products, they are going to purchase items at the counter, and then they go home with the products. And similarly, in the e-commerce sites, you will see this. You will see exactly the same process, where the shopper will first log into the website, and then they search for the items on the website, and then they evaluate items by reading these product descriptions that's provided by these e-retailers. And then they decided to purchase items by putting these items into the the shopping cart, and then they check it out until the delivery man deliver the goods to their home. Okay, so given that this shopping decision journey is exactly the same, what's interesting is that how to influence the shopper decision is up to a point of purchase, where once the shopper enter the store and before they actually make the purchase decision. Okay, so that's the place, or we call it point of purchase, where the shoppers would actually get influenced by any marketing campaigns that the retailer is providing to them. And this is known in the marketing field as the first moment of truth. So in fact, it's been well known that over half of the shoppers' decisions are made in store. So a lot of these times that the shoppers would make these impulse purchases just because they have seen those products in the store. So 40% of the customer actually change their minds due to any visual dimension factors such as packaging, the position, signage. So that actually gives a lot of opportunities for the retailers to influence the shopper's decision while they were in the store, regardless which channel they are shopping. So it's actually quite important for the retailers to understand the decision-making process at the point of purchase. That actually makes a lot of these marketing campaigns to focus on the shopper marketing. So in fact, the shopper marketing refers to the planning and execution of all marketing activities that influence the shoppers along and beyond the entire path to purchase, from the point at which the motivation to shop first through to the purchase. And when we talk about how the business intelligence and marketing analytics are involved over the past 30 years, we actually see three waves of the marketing intelligence. So the first wave comes at the time that the retailers introduced this point of sales system or POS system that allows the retailers to manage the purchase history using the barcode scanning. So this gives the retailers a very rich data source that includes the real-time data on all the transactions and accurate estimates of all the product sales. And second wave comes when the retailer decides to track and analyze the individual shoppers by introducing the so-called the loyalty card. That every time you go to any physical retailer, probably you are going to receive some kind of the promotions that are based on your purchase history. And this would give the retailers a opportunity to perform the targeted promotions and a very personalized customer relationship management. And recently, there is a third wave of the marketing intelligence that is trying to identify the real-time tracking of the customers as they enter the store, also known as the path to purchase. So this actually involved a lot of innovations in the shopper marketing metrics that are trying to capture the attentions and considerations from the shoppers. So this actually brings up a very new field about how to use the intelligent technology to track the in-store shopping behavior. So as we just talked about it, the consumer's search and choice behavior actually can be considered as the same type of the data, regardless of where it pertains to online shopping or offline shopping. And actually, it's quite easy to track shoppers online, as we know that every time you can generate a sequence of the click streams, that would be very easy to see where do shoppers go and where do they search the products and where whether they are going to purchase that products or not. But actually, in order to do the same, to track the in-store shopping behavior in the physical setting, it requires a much more appropriate digital technology support. So some recent technology includes RFID pass tracking. People posted on the shopping carts. Some other people also introduced the eye tracking methods to allow to capture the shoppers' attentions, and the others trying to use the wearable cameras to ask the shoppers to wear during the entire shopping process. and also the surveillance video that people used in order to monitor the security and the traffic inside the store. So in fact, in order to do that, probably we can use the more video data in the retailing. So the benefit of using the video data is that it can record and analyze the holistic shopping behavior in the situational context for observational research. Because comparing to the RFID pass tracking or the eye tracking, we can actually monitor how the users spend time inside the store, making the considerations and making the final purchase decisions. And a lot of this video data has been introduced in analyzing the shopper behavior, such as monitoring the store traffic to see how the fitting room is congested, or to monitor the unplanned considerations, sales assistance, and social influence. However, there is a challenge when using the video data in the retailing. That is, encoding this video data is extremely labor intensive and time consuming. It requires a lot of efforts to manually label and read the video data to understand the shopper behavior. So that actually, if we want to use the same video data to perform the experiments setting and trying to understand how the shopper behavior respond to the physical retail environment, that would incur prohibitive cost for encoding and for understanding. So with that regard, we may need the vision understanding techniques to automate the entire process so that it will reduce a lot of these human efforts. So from us, the main contributions from these projects is that we provide the empirical evidence of the product placement effect on the consumer search and choice behavior. This was already known for quite a while, that people would believe that the product placement had a very strong effect on the consumer's choice. As one of the famous marketing books says, the eye level is the buy level. It implies that the consumer, the shoppers would only purchase the items when they see them in the store. Okay, and there are some evidence showing that the products that are placed at the end of the aisle or in the middle of the shelf actually are going to sold more. But unfortunately, there is very little evidence to show the underlying mechanism why the product placement would actually drive the consumer to make such a choice. And there is also a mixed evidence on how the product placement would affect on the shopper's preferences. So sometimes people would argue that the favorable position would incur lower search costs to draw the shopper's attention, while the other believe that the favorable position would provide the shopper with a higher perceived quality. And there is no conclusive evidence, and people have still very little empirical support on really whether it's true or not. So in our case, we are trying to build up the setting that allows the product to be placed in a very similar way as the online shopping interfaces. So that will present the product in the unordered list of the slots. So as you can imagine, that normally you go to the e-retailer websites, you will see these products that are in a list of the orders. And that's what we want to do. And then we want to see if the such placement in the physical retailing would also have the similar effect as in online retailing. So, some other contributions includes that this work also added to the literature to understand the shopper search behavior and path to purchase in the physical retailing. So it's been well known that consumer needs to engage in a very costly search before making the purchase decisions. And the valuation on the product attributes actually would need to update the consumer's belief and form a consideration set during the search process. And after they decide a small consideration set, and then they are going to select only from this consideration set to make the purchase. And there have been a very consistent results in the online retailing that the products that are in the favorable position would have more clicks and purchase at the top positions. So this has we have seen application in the shopbots, sponsored advertisement, search engines, reviews, and recommender systems. But if the consumer observed the product positioned randomly, so there is one article showing that although the top positioned product will still receive more considerations in terms of clicks, however, conditional on the click, the purchase likelihood remains constant across the positions. So this actually implies that there is a chance that the products will not be purchased just because of the will be purchased just because of its favorable position, not because of its product attributes. Another contribution that we have is that we contribute to the digitization of holistic in-store shopping behavior to capture the metrics that are indicative of the shopper decision process. And although, as I said, there are a bunch of the digital technology that allows to monitor the in-store shopping behavior, but video tracking solutions are seemingly the less intrusive and more comprehensive way to capture the shopper behavior because it has been shown that by encoding each hour of the video data would take more than 4 hours. So that requires a lot of efforts. And in the previous literature, people have used the video data. Normally, they only use quite a few hours of the coded video data. But in our setting, given that we are going to run experiments that takes almost like 1 month of the entire video tracking. So it's actually would not be possible unless we are using this automated process. And one last thing about video tracking is that it might raise the privacy concerns because if you are letting the videos to be recorded for all the shoppers, then their identity will be revealed afterwards. So we want to use a non-intrusive video tracking technology that not only is able to automatically identify the shopper behavior, but also trying to hide their identity after the study. So now I'm going to introduce my experiment design. So we have been working at an independent bookstore located in the residential area in Lisbon, Portugal. This bookstore opens 7 days a week selling books, newspapers, magazines, stationery. So just like any these normal bookstores. Normally, this is on the right, you will see a layout of the bookstore. So normally this bookstore will receive the new books from all the leading publishers in Portugal, and then they place them on the top of some large tables devoted to the new releases. And so our focus will be on this very specific table that is always display the most recent released books. And over the time, these books will be replaced by other latest books, and the old books will be redistributed to other tables throughout the bookstore categorized by the themes. So in our case, why we want to do it in a bookstore? First, books is considered as horizontally differentiated experience good that would have a high search cost. And it's been very useful earlier that recommender system will be very helpful for the experience goods in the online setting. So in our case, given that we are experimenting the latest released books that are placed on top of the front display tables with 30 slots. So given that these are completely new books, so that the shoppers would have a very limited prior knowledge about these books, and they tend to rely on the information gathered in the bookstore to make the purchase decision. And another thing is that normally some other studies that are trying to identify the effect in the physical retailing would have the problem when the online retailing have the same products, but with a much lower price. So you can consider that from the Amazon. However, in Europe and in Portugal specifically, the new book prices are fixed under the regulations, so that it will preclude the possible price competition and to alleviate the showrooming effect. That is, people just go into the store to search for the information, and then instead they buy it online for the lower price. But actually, it's not possible in our setting, because all the books, regardless whether you are going to buy it in offline or online, it will have the same price. So given that we are going to randomly put these books on these large tables in 30 slots, in fact, we are going to randomly put them into the 5 rows and 6 columns, as you see on the right. So every time we are going to generate a random sequence of numbers between 1 and 30 and place the incoming books according to that number on the top of the table. At the beginning of the experiment, we randomly shuffle the books that is already on the table. Okay, so this is the table that we are trying to perform the randomized experiment. And every time, whenever there's a new book coming in, we are going to put them according to the previously generated random positions. So here is illustration of how we actually perform the experiment design. So at the cycle 1 and 2, every time when there is a new incoming books, and we are going to check the random number that we have generated before. And we are going to replace them to the position that is already being occupied by some other old books. And we are going to place them in these incoming books according to the random sequence that we have. So every time there is a new books coming in, and then the staff in the bookstore will check the position, and then they are going to put it into the slot. And in fact, if you see this book, this big table, and given that there are about 30 slots, and we believe that those slots at the edge of the table, that is around 14 slots in the edge positions, are more accessible than the ones that are located in the center of the table. Okay, so in other words, these books that are randomly placed at the edge of the table would have less search cost compared to those ones in the center. And so that actually makes our all the books to be categorized into 2 groups. One group with the 14 books in the edge positions in the treated group, and the other 16 books in the center positions as our control group. Okay, so this is how we actually randomize the book positions, and we are going to see how the shoppers would respond to this random placement of the products. And in order to capture the shopper behavior, we also need to build up an in-store tracking infrastructure to allow us to do so. So in fact, we are going to use this the so-called 3D sensing infrastructure that was enabled by this 3D camera from the Microsoft Kinect. So it includes 2 programmable sensors. One is the RGB sensor, and the other is the depth sensor. So in this study, we are mainly using the depth information. So the RGB information is used only for the validation purpose. So in other words, this depth information would help to improve object detection and tracking reliability over the regular camera, and it also much less intrusive without interrupting shoppers. And by using the depth information, it also becomes easier to handle the situations such as occlusion, and is less privacy threatening and invariant to the environmental changes such as lighting conditions. So we installed the camera right on the top of the ceiling to monitor the entire area of the table, and then we are going to monitor the holistic and shopping behavior during the entire experiment. And this was a technology provided by my colleagues at ISR that was used for tracking the traffic in the airport. And it shows very robust tracking behavior also in this bookstore setting. So as you can see here, given that our camera was mounted on the top of the ceiling, and we can see the entire area close to the table of these new books. So this is, as you can see, all these books were being randomly placed at the table, and then our camera would be able to capture both the RGB and depth information here. But noted that we are only using the depth information to capture the shopping behavior, so that no shopper identity will be revealed afterwards. So here, as you can see, our tracking infrastructure is able to detect the shoppers whenever they enter the scene, and they will be showed up in these bounding boxes, and they will start to record the videos. And so in order to do that, that was enabled by the 3D tracking information that build up this 3D representation of the space. So whenever a shopper enters the scene, and then we will detect this shopper and then track their behavior during the entire search process and purchase process, of course, and then they will start to recording the depth videos and until they exit the scene. Okay, so in other words, this would be a way to allow us to only record the videos whenever there is a shopper comes closer to the table. So as you can imagine that given the month-long experiments, we don't have to decode a lot of these videos, but only for those ones include the shoppers on the site. And furthermore, in order to help us to identify which book that the shopper is interested in, we actually also allows to monitor the changes on the table, so that if a shopper picks up a book and then decide to take that book away when they making the purchase, and then of course there will be a changes on the table layout, so that we will show, as you can see here, one of the shoppers decide to take a book with him or her, and then we will see directly on the table layout that there is a change on the table, so that it allows us to quickly identify which book have been picked and have been purchased. So this would be very helpful for us to collect the shopper's behavior data, and this save a lot of efforts afterwards. So let me talk a little bit more on the advantage of using such 3D tracking. So first of all, compared to many other ways, digital technology that are capturing the shopper behavior, this would allow us to give a non-intrusive way to digitizing the holistic in-store shopping behavior. And by using these vision understanding algorithms, it helps a lot to lessen the efforts of video encoding process. And last is that our technique is considered as a privacy preserving technique, that if you want to do any marketing analysis in the physical retailing, that would not reveal any this personal identifiable information. Okay, so in other words, we believe that this 3D tracking would be an appropriate technology to be used in the store, in the physical retailing, that that is considered have this so many advantages over other existing digital technologies. Okay, so now I'm going to talk about the data that we have used and the result that we have. So essentially, we performed this experiment for about over a month. And then we have include in total 90 books that can be categorized into 42 books in the treated group and the other 48 in the control group. And we only record the depth videos that contain the shopper activities, that is, their pickup and takeaway behavior of the books from the table. So in total, there are about 90 hours of activity videos during the entire 450 working hours. So in other words, our 3D tracking technology eliminates over 80% of the encoding process. Okay, so we used in total 2 metrics that are indicative of shoppers' decision-making process. First is that if the shopper, after they browse over the display table, they decided to pick up a book. That is the time that they are interested in that book, and then they decide to further evaluate that book. Okay, and after they start to read some description or the text inside the book, they might decide whether they want to purchase that book or not. So they can decide whether they are going to take that book after reading through its content, or they are going to put it back. Okay, so in this case, we are going to collect the information about whether shoppers would pick up a book and whether they are take that book after they finish the evaluation process. So in total, we have collected about 1,200 customers that pick up 1,700 books, then took about 122 books. Okay, and then as you can see here, we have the number of the picks and number of the taken and number of picks by day and number of taken by day. And then we show them there is actually a significant difference between the treated group and control group. And we also use a lot of these book characteristics that have been found to affect sales, just to ensure that we control for all this unobserved heterogeneity across the different books. That includes number of the page, whether this book is a paperback or a hardcover, whether it's been translated book, what is the price, how many days it has been displayed on the table, and it's a review from the Goodreads.com. And one thing that we want to make sure is to look at whether the treated group and control group would be balanced or not. And actually, when we look at the book characteristics, the books that are in the treated and control group actually have the similar characteristics. In other words, our randomization process works as expected to randomly put the books, regardless of its characteristics, into the treated position and control position, so that the only metrics that may affect their sales would be the placement that was being randomly assigned to them. And after that, we just perform the regular econometric model and to identify what would be the effect of the books by using the regressions. So in this case, we have like 2 different specifications. First, if we look at the book level, so each book will be considered as one observation, and the dependent variable will be how often the shoppers would pick and take each of the book. Okay, so that the D will be the dummy variable that indicates whether that book is placed at the edge or the center position, or it was being placed into the treated group or control group. Well, we also include a bunch of these the book characteristics as the control variable. And another model specification would consider the visit level specification. That is, we treat each of the shopper's visit as one impression to a list of the 30 books presented on the table. So you can consider this similarly as in the online setting, that you have like the information, say whether the visitors is going to see the presented book list, and then whether they are going to buy during that impression or not. Okay, so that our dependent variable will be whether that shoppers would pick up and take the book during that specific visit. And more interestingly, we are also examining whether the shopper will take that book after picking up that book. Okay, so our identification actually is enabled by the experiment design itself. So typically, as we know, that book placement is subject to the manager experience and is, of course, are correlated with many different factors, such as book characteristics, displaying arrangements between the publishers and bookstore. And in our case, given that all the incoming books are treated and random to be placed on the top, so that all the search costs are also independent. And another good thing of using the randomization process is that it also facilitates what we call a masking process. In other words, given that we are experimenting on the new books, the publication date were determined by the publishers. So there is no way for us to actually know which books will come in what order. And when they've been placed into these predetermined random sequences, so we are actually ensuring that there is no any this interference from either us or the book managers that actually determine which book should be placed into which position. And our robust and unobstructive video tracking technology would capture the shopper's truthful response and may help reduce those so-called attrition problem, so that the shoppers would not notice that their behavior was being tracked, so that they are not going to actually intentionally perform their behavior under such expectation. Okay, so I'm going to show you some results now. So not surprisingly, when we look at the treatment effect at the book levels model specification, we see that the books that are placed at the edge of the table are picked 109% more often per day than those at the center of the table. In other words, these books that are being placed into the on the edge of the table are actually much more likely, about 2 times more likely than those one placed on the center of the table, just because they are being placed at the edge. Okay, because we know that the books that are placed in the center and at the edge have no systematic difference between them. And also we show that these books placed at the edge of the table are being taken 67% more often per day than those at the center of the table. So that actually is quite important, because it looks like that this book will be sold 60% more often, just because they are being placed at a favorable position. So this is actually confirming the previous evidence that the books with the less search cost would actually have much more sales. So in this case, we also confirm that. And if we are looking at the treatment effect at the visitor level, we also see that not only that the books that are placed at the edge position would have more picked probability and taken probability, but also we conditional on picking the book, we show that shoppers are equally likely to take the books placed at the center, edge and at the center of the table. So in other words, after the shoppers finish up their browsing stage, and then they decided to pick up a book, and whether or not they are going to purchase that book is only subject to their opinions after they evaluate the book contents, whether they like it or not. Okay, so why the books that are being sold more at a better position is simply just because they are being placed at the edge of the table. Okay, so this is the first time that we are able to show that such search cost would have a causal effect on the book's the performance, just because it has a better position. And we also perform some kind of the robustness check by looking at whether our randomization is happening only because it was designed by chance. So we are using this so-called random inference technique by simulating all possible random assignments to generate the counterfactual outcomes. So in this case, we are going to adopt exact test statistics with finite sample sizes under the sharp null hypothesis to create a reference distribution. And then we will calculate the p-values under the alternative hypothesis. So this now becomes quite important after the recent argument from one prominent economist that they re-examined all the experiments from all the top economic journals, and then they found that up to 50% of the papers become not significant at the same level by using the randomization inference. Okay, and then we decided to perform the randomization inference steps in this four steps. First, we generate a hypothetical random treatment assignments to books from our randomization assignment mechanism. Second, we calculate the test statistics of the difference in means between the assigned treatment group and control group under that hypothetical random treatment mechanism. And then we are going to repeat the step 1 and 2 for about 10,000 times, and we construct a reference distribution under the null hypothesis. And fourth, we compute the p-value as the proportion of the reference distribution that is at least as large as our actual experimental test statistic in absolute value. So in other words, we are trying to make sure that our results are not purely because of the random assignments by chance, but just because the causal effect that we are trying to identify. And here we actually show that the books that are placed at the edge are with about 108% more often than those at the center, with the significant the p-value about 0.001 level. And similarly, we also show that the books that are placed at the edge would have taken 72% more often than those at the center, also with the p-value at 0.01 level. So in other words, both of our results that we obtained earlier would be statistically significant and robust to any this randomization assignment that we are trying to perform. Okay, so after I present you the results, I would like to give you a very brief discussions on what we have found. So first, we are among the first to perform the in-store randomized experiments while accurately capturing the shopper behavior in real time. So we found that the books that are placed at the edge of the table are much more likely to be picked and taken than those placed at the center of the table due to the saliency effect. That is, these books just simply because they are putting at a better position. But also we show that the book placement affect the consumer choice through its effect on the search process, but not through its effect on the consideration process. So this is something that was not shown any time before, because we show that conditional on the search, on the picked behavior, the consumer have no the preferences over the books that are placed at the edge or at the center. So this actually gave us a possibility to perform this experiment in the physical retailing environment that essentially resemble the dynamics of the digital recommender system in the online bookstore that has been used so heavily today. So what are some implications? So first is that the bookstore manager may leverage this result by maximizing the profits by strategically place the books with the higher margins at the center, at the edge of the table for longer durations, because that actually would make their profits to increase, right? And also, the success of the new products, such as the newly released books, may depend critically on the placement that is assigned by the retailers. Given that there are more and more new products that are hit the market, the bookstore manager may strategically favor some publishers and thus enjoy the market powers through the design of the recommendation scheme. And one of the things that we perform the recommendation mechanism in the physical retailing is that it's not personalized recommendations. So it will favor those products at a better position more strongly than the online personalized recommender systems. So in other words, the sales of the products in the physical retailings may become more concentrated and amplified towards those with a better placement. And some limitations of this work is that this work, given that we only perform that in the physical bookstore, so maybe it does not really generalize well to those other goods do not have the limited prior information. For example, if you are looking at the products such as the breads or milk that people typically purchase more often, and then they are more knowledge about it with the more personal preferences, probably the product placement would have much less effect than it was showing here. And the price effect of the consumer search and choice is not studied in this case, okay? So sometimes the consumers might be willing to pay higher search costs to locate the cheaper products, so that was not showing up in this one. And third is that how can we convert the shoppers into the buyers through the recommendation mechanism remains a challenging question. And this is something that we would like to address in the current working. So now I'm designing a recommender system in the physical retailing that is located right on the campus at my university. So we are building up a Amazon Go style laboratory supermarket in collaboration with a large Portuguese supermarket chain. And in this supermarket, the shoppers, when they enter the store, there is no sales assistance, and they are going to scan the products using their mobile phones, and they are going to self-checkout with the frictionless shopping experience. So in this case, we are trying to design a recommender system and use computer vision to track the shopper's response to those recommended products. And we have already finished up the implementation, and we are planning to deploy it in the spring 2021 after the COVID pandemic passed, hopefully. And so we are going to further examine whether the product placement and recommendation schemes would work in a similar fashion as it was shown so successfully in the online retailing. Okay, so that's all about my presentation, and thank you very much for attending. And if you have any question, please let me know.
Yes, thank you, Kiva. This was very interesting insight in our, I think, human behavior.
Yes, it is.
Yes, and that already brings up the first question. If it's really so that, yeah, it's really when you place a book at the edge of a table in the middle, in the center of a bookshop, and this is basically more taken than the ones who are in the center.
Right.
It means it's, I understand it's a visual effect. I mean, this is.
Yes, so the next time probably you should not just purchase the products that are being placed at a better position. Maybe the retailer wants to sell you with a higher price.
Yes, just my question comes here. Is it possible? The key is what you said before in your presentation on the bookshop. It's there is the content question. You go in a bookshop because you want to have the recommendation of the book owner. That's the key, no?
Yes.
So it's basically, and if you find out that it's only because of making profit or margin, he puts books out there, and not because he thinks they're great. That's of course somehow. Do you think there's a problem?
Well, I have to say that actually this was a common practice in the physical retailing every day. So probably you would know that a lot of this the product manufacturers, they actually pay a slotting fee to the retailers in order to place their products at a better position. So every time if you see there are some salesmen or saleswomen at the aisle of the shelf that are trying to promote some of the items that they have, right? So these are very typical process that was being enabled in the physical retailing for many years. So this is a very common marketing strategy, but the underlying mechanism was less understood before. And we are trying to provide a methodology that are capturing the holistic shopping behavior and to show that the product placement indeed have a very strong effect on the shopper's preferences.
Yes, thank you. And you also showed your next project, the supermarket, right?
Yes.
This is your project now. So
yes.
There comes my second question. I mean, you said you want to have non-intrusive video cameras. You did this experiment at the bookshop with non-intrusive Kinect 3D tracking. What are you doing in the supermarket? You're also using 3D Kinect tracking, or just video cameras?
So the bookstore experiment is limited to one table with just the one camera, right? And now, given that we might be interested in more the entire path to purchase from the shoppers whenever they enter the supermarket, so that actually involves more cameras. And these cameras do not really review the personal identifiable information, but instead they are going to capture such as whether the shelf was being taken by the shoppers and how many shoppers in the store. So it was used to monitor some aggregated statistics rather than looking at the individual behavior. And in order to identify the individual behavior, we have the mobile apps that would record their purchase history. So in that case, the camera was used for the different purposes.
Okay, thank you. And what will be your next project after that? Do you have already exciting outlook? What comes after your project? Do you have any idea what you're doing next?
Besides this physical retailing project?
Yes.
Yeah, so we are actually also collaborating with some healthcare provider and trying to provide the recommender system for them to allow them to matchmaking between the patients with the family doctors. So in that case, the patients will be recommended a list of the family doctors that are considered to be the best match for them. So in that, the question is that we want to build up a trust between the patients and doctors during the recommendation process, and we want to enhance the long-lasting patient-doctor relationship in there. So we are also at the stage of deploy that recommender system, and then we want to see whether that will increase both the welfare from the patients and also increase the relationship between the patients and doctors.
Okay, thank you. So, like always, we are coming to the end. It's already 5 minutes before 4. It was a long, great presentation and
Sure.
very exciting work. May I ask you, is this presentation available? Will you share it or not?
Yes, definitely. I'm happy to share.
Great. So if you, any of you participants out there, wish to have it, please notify me or Kiwei directly, and I think he will share it with us.
Yes.
And great. So this is, thank you very much. And I also will have a recording, which I will send to Kiwei first, and then hopefully we can publish it in the next days online. So thank you. And now my last, before I have to announce also tomorrow. So I change now the moderator role to me, and that's the last thing for today. One moment. Let's see if we are there. Yes, we are there. One moment. And it comes. Okay, so, and then for the ending tomorrow, please come back to the cafe on December 10th. That's tomorrow. The speakers are Nathalie St-Pierre. She's a president founder from SDG Capital Corporation from Canada this time. And Patricia Gautrine, PhD student in ethics of artificial intelligence, president of intelligence, NAPSE, NAPS, with their talk on AI lifecycle, the data journey, unlocking patient capital for the 17 SDGs. So thank you again, Kiwei. This was great, and have a nice day, everybody. Bye-bye.
Thank you very much. Bye. 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 Bye.
Bye. Thank you.